Okay, so we were talking about the DTM process yesterday. So let us continue with that. Any questions till this point do you have?
No, Ajay, I'm good.
Okay, so now we are clear about what an integration service does, what are the different major processes which runs inside an integration service, that is an
Yes,
integration service process, load balancer process, and DTM process. So each of these processes have their have to take care of their own tasks. So there are certain set of tasks which each of these processes do. Like for example, your integration service process is responsible for everything related to execution of the job, right? So
yes,
like everything which is related to your maintenance of your workflows for the execution of the job is handled by the integration service process. Okay, like reading the parameter file, scheduling, maintaining the schedule of a workflow, okay, authorizing the users to read or to have a particular set of permissions on a workflow, locking of the workflows, okay, running the workflow tasks, and wherever required, starting the DTM process for taking care of the load end to end, start till end. The execution of the job, it has to take care of the load, right? Starting from reading the data till writing the data. So that is done by the DTM process. DTM process is started by the integration service process. Now, maintaining your run information in the repository metadata is also done by the integration service process. And if you have any post session emails after the session is successful, if you want to send any emails or any kind of post session activities you want to do, that will be taken care by integration service process. Now the roles and responsibilities for each of these processes are well defined, right? Similarly, your load balancer process has certain properties, and it does mainly the job of the load balancer process is to run your or to distribute the load across different nodes within a grid. Okay, so
okay,
so that the maximum utilization of the resources is done, proper utilization of the resources is done, and the jobs are completed in a specified amount of time to properly utilize the resources and to get the maximum performance benefit out of your architecture. The load balancer service dispatches and it balances the load, balances the allocation of resources within your different nodes. So that is done with the help of certain properties, right? So when we talk about the load balancing properties, we talk about resources. So it looks into which node has what kind of resources. Accordingly, it will dispatch, right? Dispatch
yes,
process is there within the load balancer, which is responsible for dispatching the jobs. So when we study in detail about the load balancing concept, there we will also talk about the dispatcher services and all these other stuffs. Okay.
okay,
Yeah. So then we have the resource provision threshold, dispatch mode, service level. These are the other set of properties or other supporting factors which helps for load balancing. Now coming to the core concept of DTM, right? Data Transformation Manager. DTM is responsible for your end-to-end overall load, reading from the source and writing till the target, along with handling the parallelism as well. Like if some parallelly if some records need to be processed, that also needs to be handled by the DTM process. Okay,
DTM
so
process.
now that depends what's the load and what's the kind of request or what that particular mapping is handling. Based on that, multiple DTM processes can also run at the same point of time. So
Okay,
uh, yes, so that is the whole point of having this DTM process helping in the load. Now we are going to understand that exactly in details that what are the different tasks which the DTM is doing. That's what we will talk more about the functionality of the DTM today, right? So when we say that the DTM process is helping in the overall load, it is helping in reading from the source and writing into the target. That overall thing, what is happening in between, right? So reading from the source, and it's not just reading from the source and writing the data into the target. In between, a lot of transformations are there in your mapping, right? So the
Yes.
transformations also need to be handled. So that is also handled by the DTM. And for that, a lot of memory is needed. So the proper utilization of the memory also needs to be done. How much of memory is needed for a particular transformation, how many rows it can accommodate, all those things are also handled by the DTM process, right? So this thing we will see. So what are the basic tasks with which a DTM process does? So the main tasks is, this is responsible for reading the session information, not log, the session information which the integration service provides. So the first thing is, when does your DTM process start? Who starts the DTM process? The integration service process triggers your DTM process, right? This integration service process
Yes.
starts your DTM process, right? So uh, all the session related details is passed on by the integration service process to this DTM process. So it will read all those information. That means, what is the session name? What are the connections? Where does this session, under which folder this session resides? Under which workflow this session resides? All the information about that session is read by the DTM process. It takes these information from the integration service process. Okay, so that's the point here.
Okay.
Next, the DTM process, after getting the session related information, it also needs the metadata information. It has to run the job. It has to read from the source, right? And it also needs the target information. In short, it needs the complete metadata about your mapping. So it retrieves the mapping and session metadata and also validates it.
Okay.
Before running the job, it does a validation. So that's why sometimes you'll see an error. If you're running a job, that job is invalid, then it fails in the beginning itself without even triggering or without even writing something into the log. It fails it at the beginning. So first validation happens. So when the DTM process receives this request from the integration service process to do something, it first asks for all the information related to that session. Then it asks for all the metadata information for that session. That means, what is the source, what is the target, what is the meta, where is the metadata, what is the ID of that source. All the metadata information is taken by the DTM process, and it validates that metadata information, whether that mapping and all things are valid or not. Third thing is,
Okay.
it does is, now the integration service process will also pass the whatever parameters and variables are needed. I told you, right?
Yes.
Parameter file is initially itself checked by the integration service process. Now all these values will be passed on to the DTM process. DTM process will take all these values. Now it will try to expand those parameters and variables.
Okay.
And during that time, if some issue occurs, it might also fail. Like while expanding, if some issue occurs. Now, if let us say integration service process checked, read the parameter file and checked certain parameter is there. DTM process, when it started running the job and it tried expanding that parameter there, due to some data type mismatch or due to some issue there, it failed. Then that failure will be handled or will be written in the session log by the DTM process. Okay, so expanding of parameters and variables is done by the DTM process.
Okay.
Okay, and if you want to run your job in multiple partitions, if you want to do a parallel partitioning, that means parallelly you want to run multiple threads. We'll understand the concept of thread now after this. So if you are running multiple partitions, then all those partitions are handled by the DTM process. Okay, so formation, partition groups and dynamic partitions is done by the DTM process, right? So whatever partitions are needed, whether dynamic or static, and if some partition groups need to be created within your mapping, that is also handled by the DTM process. So basically that's a part of, your overall load, right?
Yes.
So that's why the DTM process will be responsible for handling that.
Okay.
Now, if you are doing, so have you heard of the performance optimization techniques in Informatica PowerCenter? Have you ever done or heard of parallel partitioning or push down optimization? So
No,
there's a
Ajay.
technique of performance optimization in Informatica, which is known as your
Mm-hmm.
push down optimization. Okay, push
Okay.
down
Okay.
optimization means let us say at the source end or at the target end, if you want to push your sources or if you want to push your data, convert it into SQL, into the database format, SQL database DDLs, sorry, the database DDLs and DMLs, and push it to the source or the target side. Instead of the
Mm-hmm.
Informatica engine, the database server will run it. So your code will be
Oh.
converted to select queries, database queries,
Mm-hmm. Okay.
and those queries will be assigned, pushed to the source side or target side, however you configure it. If the source side is a database, if the target side is a database, either one of them, or some part to the source database, some part to the target database, it will distribute, so that instead of running in Informatica, your job will be converted into SQL queries and it will run in the database server. So that will be faster. So in some cases we do that. That is known as push down optimization. So our DTM process takes care of that. DTM process will be converting the, sending the information to the database server, interacting with the database server, and all those stuffs will be done by the DTM process. So push down optimization is taken care by the DTM process. Now, when your jobs run,
Process.
the creation
Mm-hmm.
of your session log. Okay, your session log is maintained by the DTM process. Okay, creation of the session log is done by the DTM process. Just like the workflow log is handled by the integration service process, your session log is handled by the DTM process. Whatever needs to be written inside your session log, whatever details, is all handled by the DTM process. Okay, another important thing is your code page validation. Right, so if you have code pages, so do you know about code pages? Have you heard about data movement and code pages?
No.
No? Okay.
No.
Let me tell you. So if when we try to understand this, I think as an administrator also, we should have some idea about the code page and data movement in Informatica. So in
Okay.
Informatica or any application as such, right? Mostly we'll
Mm-hmm.
talk about Informatica Power Center. The
Okay.
data which moves into different areas. That means data movement, where does it happen? It happens from source till target. Okay, and your data is moving
Okay.
from source to target, and in between the transformations are taking place in the memory of the Informatica server, right? Set of
Okay.
records or set of rows will move within the Informatica's memory from one block to another block, like that. The processing happens row by row, and the data moves from source end to the target end. That's how the data movement happens. Now, is this data movement pretty simple? Now, let us say that if we are reading some ASCII characters or English characters, okay, then that is fine. Data movement is pretty simple. Now, if we are handling, for example, let us say Chinese characters, if we are working with some Chinese data in the source, Chinese or Arabic data in the source end, which we want to move to the target. With a normal data movement mode, will you be able to move a Chinese character? So first of all, tell me, is a Chinese character a recognized ASCII character? Is it in the recognized ASCII character set? No, right? Your Chinese
No.
characters and your Arabic characters or Hebrew or any other languages, the characters which are used, they are not the standards. So they are not the part of the ASCII standards. So you won't find it in the normal keyboards or in the normal data movement. They are not considered as a ASCII character set.
ASCII.
It's
Mhm.
not even considered as a special character. It will be simply treated as a junk character. Okay,
Okay.
because that is a completely different script,
Yes.
right? And the ASCII standards is mostly it started from US, right? So it's the US standards, and they support different languages which are almost in the same script. In the script, like even if you write French or German or Italian or Spanish, you're actually using the English letters A B C D E, all these ASCII letters, and the ASCII character set is being used. So these are simple to move. These kind of data is simple to move across using any application. But these languages, which have their own different scripts, Chinese, Japanese, Arabic, Hebrew, all these languages which are having their own different character set, which is not recognized, right? They are
Yes.
not they have their own different standards. So the normal data movement mode won't support it, even if you're using Informatica application. If in the source you have a Chinese character, if you have the names in Chinese, or let us say some description is written in Chinese, you want it in your target. When you load your data, your job won't fail, but it will load all junk characters like you see in a binary file. Some boxes and all those junk character set will be loaded, since it will not be able to identify what it is. Actually a junk will be loaded, right? So
Yes.
now for handling such kind of data sets, you cannot go with the ASCII data movement mode. You have to use the Unicode data movement mode. So in Informatica, or I would say this is a standard, so any other application also, you have two types of data movements. One is the ASCII data movement mode, another one is the Unicode data movement mode.
Mhm.
Okay, ASCII will
Okay.
handle your normal ASCII character sets, in which one character is treated as 1 byte. It takes 1 byte of memory. One character takes 1 byte of memory in the application server, in your Informatica server, right? But when
Yeah.
you're treating, when you're dealing with these Unicode special characters, okay, this is known as your Unicode data movement. This Unicode data movement takes 2 characters or 2 bytes for each character. If you're writing, if you're moving a Chinese character, any one Chinese character, let's say Chinese A or Chinese B, so those will be treated as 2 bytes per character in the memory. So obviously a Unicode data movement will take more space, right? But
Yes.
then now that is the requirement based. So there a data movement is there. So whenever you go into your integration service properties, let me open it 1 second. So here you can see the data movement mode as ASCII, right? Because when you're setting up your integration service, you set up your data movement mode as ASCII. Now, if you are, if
Okay.
this integration service is going to handle some special characters, you have to change this data movement mode from ASCII to Unicode. Okay.
Okay.
So similarly for
Okay.
repository service also, I think there should be a data movement mode. So in repository service, we have a code page, right? So data movement is supported by integration service because integration service is handling your data movement, right? Your movement
Yes.
of data from source till target is handled by the integration service. Repository service is meant for your metadata support, right? So repository
Yes.
service is having code page. Now your this integration service is dependent on the repository service, right? So your integration services data movement mode, we can use only those data movement mode which is supported by what code page you have selected here. So
Code
here
page.
Latin 1
Okay.
MS Windows is selected. So ASCII data
Mhm.
movement we can select. Now there if we select
Oh.
Unicode, here we have to do now how we want to keep the metadata. Now let us say that if something we need only on the data side, okay, then we can make the
Mm-hmm.
data movement mode to Unicode. That means some data is coming from the source and we want to move it to target and some Chinese or Arabic characters, then data movement mode you can do it to uh,
Unique.
Unicode. That is fine.
Okay.
Now what
Mm-hmm.
if your metadata itself, now let us say that you are using Informatica PowerCenter itself in Chinese version, Japanese version. The Informatica PowerCenter comes in different languages, right? With different
Yes.
country support. Now we are using
Yes.
the English one. Now if you are using it in Japan, some Japanese clients, these menus will all be in Japanese. In Japan, I hope you know that they they don't like using these means
In
if you use more English, right? So they
yes.
want people to use their language as much as possible. So even the tools which they use, they want people to learn Japanese and then go there. So that's why if you're ever getting a chance to travel to on-site in Japan also, first you are means the preference is given to the people who already know Japanese to some extent, some basic Japanese,
Okay.
right? So
Mm-hmm. Okay.
if your tool itself you are using in this Japanese and your metadata you wants to be stored in that particular character set, then you will have to select your code page itself as UTF-8. You have a code page called UTF-8. I don't know whether you'll be able to see it here or not. Let me see. It doesn't allow to change now once it is set, but code page there is
Okay.
something called UTF-8. Okay, so Unicode is supported with UTF-8. So you have to keep both of them in sync. Okay, in
Okay.
those cases.
Mm-hmm.
So for all the services, you have this code, your code page and a data movement for integration service. So all of these should be in sync. Now, this is validated and handled by the DTM process. Now, DTM process will check what is the code page and validate it, whether that code page is valid as per your data movement mode or not. Okay,
Okay.
that's one thing. Another thing, your whatever connections you're having within your workflows. So validating all your connection objects is also the job of your DTM process. Now all your connection objects, whether it's a source connection or a target connection, any type of connection in the workflow manager, all of them will have permissions. All the connections, yeah. Have you seen that in the workflow manager? That your connections also have the permissions. Let me show it to you. If you go into any of the connections, right, you have the permissions tab. So which connection object has what kind of permission: read, write, execute, which user has the permission, whether it's a read permission, write permission, execute permission. See,
Yes, yes.
for this connection, the other users don't have write and execute permission.
Write and
Only
execute.
administrator has, right?
Yes.
So these permissions on your connection objects is validated by DTM process because when the job will run, if a particular user doesn't have the permission, that user doesn't have the permission to use that connection object, then that user won't be able to run the job
Yes.
because reading and writing won't be possible, right? So that will be shown as an error that proper permissions are not there. So who handles it? DTM. DTM
DTM.
validates whether that particular connection object, that user has a proper access, proper permission to handle that connection object or not, whether source or target. Okay.
Okay.
Next is now what else the DTM process does. Okay, so let us say that your DTM process has started and a master DTM process has started and it needs the help of some more worker DTM processes. Now let us say your job is running in a grid. Okay, out of that grid, there are multiple nodes. One is the master node, other are worker nodes within your grid. Okay, so
Okay.
in the master node, your job started. So your master DTM process started there. Okay, and some part of that job is also has also been distributed to other worker nodes, which is a part of the same grid. Now within a grid, if you are running, the same job can be distributed. Some threads can run in one node, some threads can run in another node. Okay, so
Okay.
now if that is the case, then the worker DTM process, who will take care of that? So this main DTM process will start all the small
Worker.
worker DTM processes.
Okay.
The other thing is, if any threads are running, right? So running the processing threads is also the responsibility of the DTM. Now we'll understand more about thread processing. What is the thread processing? Why we are talking about threads? So first, let us understand that the DTM is responsible for your thread processing.
Okay.
Okay, so any pre or post job is there, that is also run by the DTM process. So running of pre
And post.
or post session operations, like within your Informatica jobs, if you have a pre-SQL, post-SQL, or any other type of pre or post jobs, those will be taken care by the DTM process. So all these are the kind of detailed tasks of which the DTM process does. Okay.
Okay.
Now, this is the overall task which the DTM does. Now, what happens when a job starts running? The threads come into the picture. So DTM creates multiple threads. So we have to understand about the thread processing. How does the thread processing work in Informatica? And how does the DTM handle the thread? So basically, threads are nothing but kind of sub processes which takes care of a part of the load. Okay, so it's just like, I would say, the sub process which the main DTM process creates. It's nothing but a kind of a process which will be handling a certain part of the load, not everything, but certain part of the load. Like for example, reading. For reading, there is a reader thread. For writing, there is a writer thread. For handling the transformation, there is a transformation thread. And there can also be multiple transformation threads in a mapping. There can be one or more reader thread, writer thread, transformation threads. Okay, so there are different types of threads we have, which gets created when your session starts running. Whenever you run your job, the DTM process is started. Now, the DTM process will further create small threads to do certain tasks, and it'll assign certain tasks to them, and the DTM process will be handling the other supporting things like writing into the session log and other stuffs, validations of the connections, validations of the licenses or the authorizations. These things will be taken care by the DTM process, and the actual data movement will be done within the threads. Okay, so
Okay.
the types of threads we have in Informatica is we have the reader thread, which reads the data.
Mm-hmm.
We have the transformation thread. Now we have so many transformations within a mapping, right?
Yes.
So the movement of data within the transformation is handled by the transformation thread. And then we have the
Okay.
writer thread for writing it into the target. And we have two more supporting threads, which is known as your mapping thread and pre-post session thread. Pre-session thread, post-session thread, if needed. Okay, now you saw the tasks which a DTM does, right? So you're running of the pre-post session operations. This it assigns to the pre-post session thread. The mapping thread will be responsible for all mapping related tasks, validating the things, expanding the variables, writing into the session log. All these things will be done by the mapping thread, right? Supporting tasks
Yes.
required for the mapping. Now these three are important:
Okay.
reader, transformation, and writer. Now every
Right.
mapping will have at least one reader, one transformation, one writer. At least one of each of them. Now it can have more than one also, depending on the complexity of the mapping, but at least it should have, or it will have, one reader, one writer, one transformation thread. Okay, so
Okay.
whenever you run a job and you open your session log, there you will see the thread statistics is shown. So it shows you your how many reader threads you have, how many transformation threads you have, and how many writer threads you have. It shows you there. Okay,
Mm-hmm.
so without going into the session log also, you can know, or you can calculate that how many threads you are having. I'll tell you that
Okay.
how the threads are created, means how many threads does Informatica create or the DTM creates, right? So
Okay.
to understand thread, we must understand partition points.
Mm-hmm.
Okay, so partition point means within a mapping where the partition is happening. Now you might have a question that we are not doing any partitioning. This the partitioning
Partition.
is done only to improve the performance, right? For optimizing your jobs, we partition it so that parallelly more jobs or more records can be processed. That's why we partition it. Now, what if we don't partition? Then why do we need to understand partition points? Because see, from a layman perspective, you might have a question that we are not partitioning, just a simple mapping is there. Then how to understand how many threads will be created without understanding how many partitions are created. So let me clarify here that every mapping in Informatica by default
Mm-hmm.
has some partition points. Even though you create it manually or not, by default it has some partition points. Now come to any mapping. Just let me just open any mapping. Okay,
Mm-hmm.
I'm opening this session. Go to the mapping tab. Here below you see this partitions tab, right? Go to this
Yes.
partitions, click on this partitions. Here in this page, you'll be able to see how many partitions your mapping is having. Okay.
Okay.
Now,
Okay.
this mapping is a bit complex. Here we have multiple sources and all those stuffs, but still we can see partition points. So how many partition points you can see? The flags you see here, right? They are the partition points. So how many partition points you see here?
4.
4. Yeah. So it's simple. You go to this partitions tab and see the flag. That is the number of partition point we have. Now I'll explain to you how the threads are decided, how many threads is to be created, how it is decided. You now see that these many partition points are there. 4. Where are the partition points? 3 in the source. Now, the source qualifier is nothing but source. Okay, so this is used for reading the data from the source. 3 in the
Okay.
source qualifier, one in the target.
Target.
Okay.
Mhm.
So now let me tell you that by default, the aggregator and the rank, these two transformations also have a partition point. So although it's not shown here, but this mapping should have 1, 2, 3, 4, 5 partition points. Now aggregator is there, right? So aggregator by default has a partition point.
Okay.
So manually we don't create it, but it should have it. Okay, aggregator and rank have their own partition points. Now this was the mapping. Now let us go into any other simple mapping and try to see.
Mhm.
Just a moment. So I'm opening any other mapping. Let us say this one. So 2 targets are there and
Okay.
1 source. So you can see 3 partition points here. There's no aggregator or rank, so we can see 3 partition points. So like this, you
Yes.
identify the partition points. So partition points are nothing but where the data will be divided. So if you are not creating any manual partition points, if you create some manual partitions, it will show there. A flag will come and it will show how many partitions you have created. Now, by default,
Okay.
one partition point is in the source and target. Always you will find a partition point, even if you have not created any manual partition points. And if you have an aggregator or a rank transformation in your mapping, that also has a default
Part.
partition point there.
Partition.
Okay,
Okay.
so your
Mhm.
number of threads needed is always more than your number of partition points. For example, if you are having now in this example which we saw here, we had 3 partition points, right? So 1 for the source and 2 for the target. So 3
Target.
partition
Yes.
points. So we'll have total 3 plus 1, 4 threads. 1 thread more than the number of partitions.
Okay.
Okay, so we are having 3 number of partitions. So your number of threads will be 4.
4. Okay.
Okay, and what kind of
Mhm.
threads are getting created, that you will see from here. Like, okay, so here we have one reader thread to read the data, because one partition part, right? So one reader thread to read the data. Then we have one, till this there is one pipeline, right? So one per pipeline, you will say that per pipeline. So this is known as one pipeline. Basically starting
Mhm.
from the source till this target, this is one pipeline, and from router another second pipeline has been created. This from router, this second one is actually is the
Second.
second pipeline. So two pipelines are there. So in one mapping pipeline, the number of threads you have, number of partition points you have, your number of thread is one more than that number of partition points, right? So in the
Okay.
first pipeline, for this first target, the first pipeline, two partition points are there. So three threads will
Three
work.
threads.
One
Okay.
reader thread, one transformation thread, and one writer thread.
Writer thread.
Similarly, for the second pipeline also, the same one reader thread will work, one transformation thread, and another writer thread.
Writer thread. Okay.
Okay, so basically two writer threads are needed here. Two writer threads are needed. Okay,
Mm-hmm. Okay.
and two transformation threads are needed.
One writer
And
thread.
one reader thread is needed. One reader,
Ah,
two writer, each for these two targets, and two transformation threads. One will
transformation.
work till the first pipeline here. Now from here it breaks into two different pipelines.
Okay.
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 Yeah. Just give me 1 minute.
Sure.
Okay, so sorry for the interruption. So basically, what I was telling was, yeah, so number of partitions, number of threads, so they are related. Let me note it down for you. So let me summarize it so that you can cover it later. You're there, right?
Okay. Yes.
So we can say that in a single mapping pipeline, actually, I'm getting some emails. Okay, we have 15 minutes after that. I'll join. So number of threads is how to determine it is one more than your number of partition points into number of partitions you are having.
Okay.
Okay, this is how you'll determine it, where your n you can think to be the partition point, and M is number of partitions.
Partition.
So this is how Informatica will also decide that how many partitions needs to be there, how many threads needs to be created. Now let us say that you are doing a parallel partitioning, you're partitioning your job, you want to do some parallel processing, and you created 5 parallel partitions. Okay, and in one
Okay.
pipeline you are having let us say 3 partition points at source, at the target, and in the aggregator. So you have 3 partition points, and you want to create 5 parallel threads of 5 parallel partitions. So obviously your number of threads will be number of partitions plus 1. So in each pipeline you have just multiply for each pipeline. Okay, so in your pipeline you have 3 partition points, right? So your number of threads will be 3 plus 1,
3
4.
plus 4.
Okay, in one pipeline, and you want to create 5 partitions, right? So 4 into 5, 20 threads will be created.
Okay.
So that's how you calculate it. Okay, so threads are always created based on the partition point.
Okay.
Okay, any questions here?
Mhm. No, Ajay.
Okay, so you understood the concept of partitions and threads, right?
Partitions and
So
threads.
now,
Yes.
yeah, so here something more also we need to understand here. Now, what does this thread do? What does this what is the meaning of this reader thread and transformation thread and writer thread? See, reader thread is responsible for reading the data only. Reading the data and bringing it into Informatica's memory is what reader thread is doing. Writer thread, after all the transformation is completed, writer thread will write it to the target.
Okay.
Okay, and your transformation thread in between, now memory blocks are created, right? So in between the different memory blocks, how to move the data. So those thread, the transformation thread will move the records from one transformation to another transformation. That means within the memory.
Okay.
Okay, so the memory, the Informatica's memory is, that's why it's known as a DTM buffer memory. The Informatica memory is called the DTM buffer memory because
Mm-hmm.
the DTM handles that memory.
Okay.
Okay, and how much of the memory is needed is all dependent on the transformations. Fine. So memory, if you see the session log, if you run any of the jobs, if I open the monitor, show you. So I'm opening the session log. In the session log, when you go here,
Mhm.
you see that in some place in the session log, you'll see that, you know,
Thread.
the, yeah, these are the mapping, see the mapping thread. Okay, so for every activity, a thread is created. But we are talking
Okay.
about reader transformation and writer thread. Those are the important threads. Now, there are many threads. You can see this thread column. There's a director thread, which handles, you know, the other things, supporting things like some properties.
Mm-hmm.
Manager thread is responsible for. Monitor thread is there for writing into the log and showing the monitor. Mapping thread is there for the initialization of the cache memory and initialization of the memory. All those things is done by the mapping thread.
Okay.
Pre-session, post-session, if you have, then those threads are also there.
Okay.
Okay, so many supporting threads are there. Now, the main 3 threads which we want to see is, why it's not showing. Okay, I think this job has not run. Okay, there's a failure, that's why. There's no reading, and writing happened for this particular job, that's why.
Okay.
No, it happened. So you can see here DTM initialized successfully.
Yes.
Okay, so we cannot see the old logs because we are seeing this latest log. So whatever log it is showing is the latest log. So
Okay.
old log you cannot see. That log is overwritten. That day I told you, right? Log is overwritten every time. Okay, so I have some DB error because of which nothing is getting processed. That
Okay.
is fine. So it will not start. Yeah, so if it starts, it will show. So this is some password related issue for the DWH user. Okay,
Mm-hmm. Okay.
fine. So something should at least run. Wherever we don't have a target or just a file, then that should run, I suppose. Okay, so I'll not get into this because might be connections and all are missing, so it won't be able to run anything. Connection is missing. Okay, so mappings itself are invalid, so I'm not touching these. But whenever you open the session log, right? So inside the session log, you will get the thread related details. Let me try running the std type one once again. Just a moment. Fine. So I think we are not able to see this execution today, but whenever you see in the session log, right, if some job has
Mm-hmm.
succeeded, then for that
Okay.
particular job, you'll find the complete details. Now, if I run this aggregator demo again, let us see what happens. Oh, it's failing. Target issue. Okay, fine. So you will see the thread details there, that which thread is running on what, means which thread is doing what, and how much of percentage which thread is busy, right? So we'll talk about this tomorrow. I'll show this to you tomorrow, that how does it look in the session log, talking about
Okay.
the DTM. And so this is all about the DTM process basically. So we'll just need to see that in the session log, how does it look, and DTM, how does it handle the memory, right? So we'll talk about that tomorrow. We have less time basically. Okay, fine.
Mm.
Yeah, anything you want to ask or any questions you have?
Mm, not it.
Everything is fine, like you're able to get the things right.
Yes.
Okay, fine then. Fine, then we'll meet tomorrow again.